Hello, welcome to Electricity TIA Portal Learning Series Part 2. In Part 1, we have discussed the basic architecture of TIA Portal and how you add PLCs, HMI, I/O blocks, communication modules, and how you do basic communication between PLC and HMI. These all things we have learned in Part 1. And if you are new to this channel, please I highly recommend you guys to go and check part 1 also, so it makes sure that we are on same page. And also I request you all to please hit the like and subscribe button. It will help me and it will encourage me to create more kind of such videos. So in part 2, what we will be learning today is a bit of programming with some application example, and also we will learn how you download the program in PLC, and how you simulate S7-1200. So in basically this series of learning will be focusing on S7-1200 and 1500, as these are the most running platforms for Siemens. So let's start with basic programming now. So right now what you are seeing on the screen is we have one PLC. This is S7-1200 1214-C. You can take any PLC because I just prefer this PLC. So let us do some programming, and to do that, first we can do the programming in main block, or you can add functional blocks or functional codes, but for this series we will just go ahead with the main block. So before we do programming, let us discuss an application which we will be doing here. Let us assume that there is a motor which has to be controlled, maybe based on the level switch or based on the pressure. So let us assume we have to control based on the level. There is a tank. From the tank we are measuring the level. It's basically, assume it's a level switch, and when the water is full, when the tank and the water is full, high level switch, the pumps shall start to pump the water out. Okay, so this is the basic application. So we will be doing programming for this, and we will be downloading into PLC, and we will checking if it is working or not. So right now what you are seeing on the right side screen is kind of instruction blocks. So again, the basic concept of the codes, the logics is same in all platforms. Either it is Siemens or Allen Bradley or Modicon, whatsoever it is. The basic concepts are same. The only difference is in the architecture and arrangement of blocks, but the concept, the logic behind this programming is same in all platforms. So you are familiarized with one operating system like TIA Portal, so there are more chances you will be much like your task is much easy to execute for other operating platforms as well. So now these are the basic bit logic operators, like if you scroll, if you like in manual also, you can find all these documents, information about these instructions. So without wasting time, I will just go ahead with an example, so you guys will be much familiar what we are doing in. Either you can select these basic operators from here, operations, or from here as well. So I do it, it is very accessible from here, so we will do it in this way. So let us assume to run the motor, first we need an NO contact, and we will assign some address. Either you can assign through DB, or right now we just take a hardwire, so maybe I 0.0, and we give it some name. Okay, and this is like the control is start, then you have a stop, and you have a level switch, and you have a motor, and then we have stop I 0.1, then you have a level switch, which is basically an NO contact. So when it is true, you need your motor to run. So just assume it is I 0.3, then the output will be definitely a coil, which is Q. Okay, and this is certainly the motors are, the program is in such a way it's kind of a latch. So if it is latch, we have to make sure you keep the coil continuing. So you just take this address. So you make sure the circuit is closed unless until right now the application is when you give the start command, and when the level is there, the motor keeps on running till you give stop input. Okay, this is one kind of application. And if else you don't want operator to go and give stop input, you just want it to work based on the level, you can just delete it. So if you want, we can delete it now to check our program to see how it's working. We save the program. Okay, so this is kind of one application. If you want to check the program simulation, you can hit this start simulation button. Okay, so when you simulate the program, when you start simulation, first it will compile the program by itself. Okay, it will take a moment, please bear with me. As you can see, the compilation process already started. So you just click load, start all, then you are ready to go. Okay, first simulation testing your program, there are two ways. Either you can modify the blocks here, which I don't want to do first because I prefer the other way. You can go online as well here. So right now the coil is closed because we don't have any input, we don't have level switch feedback also. The more efficient way of testing a program through simulation process is creating a simulation chart. This is how you're gonna do it. Okay, here we just create a new simulation and save it in a location which is accessible to you if you want to save. So the simulation project has been created. Once this is done, it will just take a moment, like a minute or two. Basically it's creating a virtual network, virtual PLC. So virtual kind of network is there. So once the simulation window is open, you can add simulation tables in this. So right now it's pulling all the data from the program. And now your PLC is already here, your same PLC that you are using, it's already here. Then we add a simulation table, we give some address, the same address which we have used, I0.0. So if we can I0.1, 0.2. okay, that's all. I think we don't have 0.2. oh, we have 0.3. I0.3. okay, that's all. And let's start now. For simulation, let us assume, okay, I'll just put it here. If we give start command, which is true now, okay, you see, yeah, it is there. And when the level is there, you see your output is on, the motor is on. So your code, this is how you can test the program, this is how you make and test the program, this is how you create a simulation block, so which is very easy, quite easy to prepare and to execute also. So let me minimize it. So this is one kind of application where you have a tank, and maybe you have different level sensors. Maybe in parallel you can connect them in parallel. So it depends, you can play around with all those logics. So this is one kind of application. And definitely for a process, you don't want your motor to be controlled only by a level switches. Maybe there are sudden fluctuations in that. So to avoid rapid turning on and off of motor, definitely the real process, it is something different. We need a timer block to make sure the motor is running minimum time. So you can find the timer blocks. Maybe you just want to run the motor, when the level is high, you want to make sure the motor is running for at least 10 seconds or 15 seconds. So how you gonna do it is this again. Here we have timer operations. You see, here we have timer operations. So if you want to run the timer at least for 10 seconds, so in that case we have to use off delay timer. So what that it means is, when off delay timer, how it works is, when you have the signal, okay, when the input is enabled of off delay, and when the input is gone, it's still active for 10 seconds or predefined time, whatsoever it is. So let us see an example how it works. Okay, here this is T off, generate off delay. Okay, either you can double click, select the location and double click it, it will be there. Okay, or you can drag and drop, choice is yours, and put some time. I just 10s. Okay, this is the beautiful thing in TIA Portal also. You can just put S, M, depend on your requirement. We will put 10 seconds, T hash 10 seconds. Okay, now it is done. Let us test the program. So right now you are connected to a simulation virtual network or simulation PLC. You can just hit the download, and all the changings will be downloaded into the PLC. Okay, you see we have because we already simulated. Okay, now let us remove our level switch contact. Now you have seen, even though the contact is closed, it is running for 10 seconds. It will be on for 10 seconds. After that it will be off. Let us do it again. See, on, off, and by the time, if you give one more command, it is automatically reset. So this is another example, another kind of way you do it. Like another example, we can say application example. So it's pretty simple, it's not that complicated. Now let us assume that there is no level switch, it's only like control from start and stop buttons or supervision control. So, and there is no limit switch in your what we say, in your application. Let us remove the timer also. In that case, if it is toggle switches, you have to make sure it is latched. So how you gonna do it is, you create a block over here and a block, and copy this address. So you make sure your circuit is closed all the time, unless and until it's broken by NC, like stop command. So you save the changes, download the program. It will take a while to do it. Load. So you are now connected. You can test it. Okay, your 0.2 tag 2, yes, this is the one. Give it true. You see the motor is off. So when it is false, the motor is on. So it means that your push button, which is normally close, stop push button, is working pretty fine. So this application, this is another kind of application example for controlling a motor. And basically there are many different ways. This generally in industrial the motors are not controlled in such easy, simpler way. They are much more complicated tasks, And yes, this is one of the example. You may encounter the simple motors applications as well, maybe kind of start stop only small motors, or you have some pressure control, level control. But the main aim of this video is for you guys to understand like how you develop codes, how you develop logic. That's all for this video, and in our next video we will be learning more about another operations. We have plenty of another operations here. We will be learning more on this, and we'll try to do more application examples in this series. My aim is we will be doing more application examples rather than training you on what all these commands are. I prefer to do all application examples. Thank you so much. If you like the video, please hit the like and subscribe button. It will be a great help. Thank you so much. Bye bye.